Imagine this. You're floating above a calm, prehistoric sea. Waves shimmering under the rays of golden sun. Sea life thriving below you. Everything looks so profoundly colorful. The reefs, spiraling ammonites, strange fish with armored jaws. Ocean seems alive, powerful and eternal. Now picture the exact ocean, just centuries after. There is no sign of any fish nor coral. Everything has vanished into thin air. With disturbing silence, left is a huge pool of toxic water. Although this might sound fictional, however, this truly has occurred and nearly wiped the ocean clean of life. This is the story of the day the ocean turned to acid and how it could easily happen again. Around 56 million years ago, right after the disappearance of dinosaurs, Earth was finally beginning to heal from their ruling. Mammals were spreading and evolving, lush forests were spreading, and the oceans were teeming with vibrant new species. But then something happened. Something that no creature, no ecosystem, and no climate was prepared for. In an instant, temperatures across the planet suddenly spiked by 5 to 8 degrees Celsius. Rainforests spread all the way into the Arctic Circle. The poles melted, and most devastatingly, the oceans began to die from the inside out. Scientists call this catastrophe the Paleocene-Eocene Thermal Maximum, PETM, a time when carbon surged into the atmosphere so violently that Earth nearly boiled itself alive. Deep beneath the surface, pressure was building. The continents had been slowly drifting apart from a single, colossal supercontinent that scientists call Pangaea, a landmass so vast it once stretched from pole to pole. As Pangaea began to crack, molten rocks surged upward through the thinning crust. The ground heaved, and enormous rifts split open between what would one day become North America and Europe. Through these widening tears, lava poured out for thousands of years. The eruptions weren't just ordinary volcanoes. They formed one of the largest volcanic events in Earth's history, known as the North Atlantic Igneous Province. Vast rivers of magma flooded the land, releasing staggering amounts of carbon dioxide into the air. But the story didn't end there. As the planet warmed, another force was waiting to be unleashed. Beneath the ocean floor, enormous deposits of frozen methane, a greenhouse gas far more powerful than carbon dioxide, began to melt. When that methane escaped into the atmosphere, it quickly reacted with oxygen and turned into more carbon dioxide, multiplying the effect and trapping even more heat. The oceans tried to help. They absorbed much of the excess carbon to keep the air breathable. But every molecule of carbon dioxide that dissolved into seawater formed carbonic acid, and acid doesn't play nice with life. Slowly, the chemical balance that had kept the oceans stable for millions of years began to tip. The pH level dropped from its usual 8.2, just a small change on paper. But in chemistry, even a small shift can be catastrophic. The ocean is full of tiny builders, microscopic plankton that create shells out of calcium carbonate. They're the foundation of the marine food chain, the invisible architects of life beneath the waves. But as acid levels rose, their shells began to dissolve faster than they could rebuild. Coral reefs followed the same fate, their skeletons crumbling in the corrosive water. Entire species of plankton vanished, and with them, the oceans lost their foundation. Shellfish populations collapsed. Fish had nothing left to eat. Predators turned on each other, and even the deep sea, once thought to be safe from surface chaos, began to suffocate as oxygen levels plummeted. The oceans weren't just acidic anymore. They were dying. Vast regions turned into lifeless, dead zones, where not even bacteria could thrive. On land, the transformation was just as brutal. The air grew thick and humid, and rain turned acidic, leaching nutrients from the soil and poisoning rivers that fed back into the sea. Tropical storms became constant, reshaping coastlines and flooding lowlands. In the Arctic, temperatures rose to levels you'd expect in Florida today. Crocodiles basked in swamps near the poles, and palm trees grew where glaciers once ruled. Some mammals adapted by shrinking in size to cope with the intense heat. Others fled to cooler regions, or vanished altogether. Earth had become a greenhouse world, a steaming, chaotic planet where oceans boiled with acid, and the land shimmered under an unforgiving sun. It was a time when life didn't just struggle to survive, It had to completely reinvent itself. You might wonder, in a world like that, how could anything be left alive? Well, somehow, life refused to quit. Sharks, for example, barely blinked. Their bodies are made of cartilage instead of bone, which meant the acidic oceans couldn't touch them. While so many species crumbled, they just kept gliding through the murky waters, as if nothing had changed. Then came the jellyfish, nature's quiet opportunists. With so many predators gone, they multiplied out of control, turning the seas into endless, glowing clouds of drifting life. Even some plankton managed to adapt. A few species evolved thicker shells, while others changed their chemistry completely to survive. It was as if evolution had hit fast forward, life experimenting, failing, and trying again at breakneck speed. But adaptation came with a price. Down in the black mud, bacteria were feeding on the remains of the dead, releasing hydrogen sulfide gas, a purple, poisonous fog that made huge parts of the ocean toxic. The planet seemed to be losing its mind. Yet somehow, through the madness, it was also learning how to balance again. And then, slowly, almost imperceptibly, the world began to calm down. Not overnight, of course. It took hundreds of thousands of years. But the eruptions eventually slowed, and the methane stopped pouring from the sea floor. You can picture Earth like a feverish body finally cooling off. Rain and wind began breaking down rocks, and that slow, natural process started pulling carbon dioxide back out of the air. Bit by bit, the oceans began to neutralize. Life returned, cautious but determined. The New World belonged to survivors, smaller, tougher species built to endure heat and scarcity. Tiny mammals scurried through steaming forests, distant ancestors of the creatures that would one day evolve into us. But make no mistake, the oceans never truly recovered. It took more than 200,000 years for the chemistry to stabilize, and even after that, the planet carried the memory of what had happened. Today, scientists can literally see this story written in stone. When they drill deep into ancient seafloor sediments, they find a razor-thin red line, rich in carbon, marking the moment the oceans turned acidic and life nearly fell apart. It's a warning left by deep time itself. And here's the part that should make you stop and think. We are releasing carbon faster than anything Earth experienced back then, about 10 times faster. The PETM unfolded over tens of thousands of years. We're matching it in less than 2 centuries. Shellfish farmers today are already noticing drops in pH that mirror the earliest signs of ocean acidification. Coral reefs are bleaching and dissolving faster than they can rebuild. It's the same sequence of events, just happening at a pace nature has never seen before. The PETM was Earth's test run, a glimpse of what happens when the balance tips too far. This time, we're not witnesses, we're the ones turning the dial. If the oceans die, the planet won't be far behind. They give us every second breath we take, feed billions, and keep the world's climate steady. 56 million years ago, that heartbeat nearly stopped. The seas turned acidic, life collapsed, and it took more than 200,000 years to recover. Now, we're pushing the same systems to the brink again, only faster, much faster. You might think the ocean is too vast to break, too deep to change, but it isn't. Every ton of carbon, every degree of heat, every coral that turns white, it all adds up. And the line between balance and collapse is thinner than we imagine. So when you look out at the waves, remember this. The ocean doesn't forget. It remembers every rise, every fall, every choice we make. And if we keep testing its limits, it will remember how we ended it too.